Hello everyone, this is one of my most favorite math challenges and we can call it relocation of 2. The description of this question is fairly simple. So we have got an integer number. We don't know how many digits it has, but it ends with 2. If we move this 2 from the last digits to the first digits, well, all the other digits remain unchanged. And we will find the value of this new number is equal to twice of the old one. So now I'll ask you to work out what the original number is. And trust me, this question is not simple. And you have to use the computational skills, logic thinking, and more importantly, the persistence to crack it. So you can pause this video at this point and spend as much time as you need to crack this question, and hopefully you will get it solved. And then you can come back for the solution and the explanation. Okay, now let's work it out together. So actually there are not many clues for this question. So the old number ends with 2 and the new number starts with 2 and all the other digits are the same and the value of the new number is equal to 2 times of the old one. So we start with the last digit of the old number, which is 2, and because the new number is twice of the old number, so the last digit of the new number must be equal to 4, no matter what the other digits are. Okay, so hopefully you agree with me on that. And also, if you remember how this new number is created, so you can deduce the second from the last digits for the old number must be equal to 4. And then, because the new number is twice of the old number, so 4 times 2 is equal to 8. So the second from the last digits of the new number must be equal to 8. And similarly, the third digit from the right for the old number must be equal to 8. We can just follow this strategy to work out all the digits one by one for both new number and old number. Okay, and 8 times 2 is equal to 16. But here you can only write 6 in the new number and remember to add 1 to the next digit. And the next digits for the old number must be equal to 6. And 6 times 2 is equal to 12. And remember to add 1 here, so we will get 13. And we can only write 3 here. Again, remember to write 1 to the next digits. And the next one for the old number is 3. 3 times 2 is equal to 6. And remember to add 1, and 6 add 1 is equal to 7. So we write 7 here, and 7 for the old number. 7 times 2 is equal to 14. We write 4 here, and 4 here, and 4 times 2 is equal to 8. Okay, remember the last one is 14. We have to add 1 here, so we have to write 9 for these digits. And 9 for the old number. 9 times 2 is equal to 18. We write 8 and remember to add 1 to next digit. And the old number 8. 8 times 2 is equal to 16. And add 1 is 17. We write 7 here and 7 for the old number. 7 times 2 is equal to 14. And add 1, so we got 15. So write 5 here for the new number and for the old number. And 5 times 2 is equal to 10. And because the last digit is 15, so we add 1, so it's 11. Write 1 here and 1 here. And 1 times 2 is equal to 2, and add 1 is 3. And 3 for the old number. And 3 times 2 is equal to 6. And for the old number, 6 times 2 is equal to 12. We write 2 here and 2 here. And 2 times 2 is equal to 4. But the last digit is 12. We need to add 1, so it's 5 here. Okay, and 5 for the old number. And 5 times 2 is equal to 10. So we can only write 0 here and 0 for the old number. And 0 times 2 is equal to 0, but the last digit is 10. So we have to write 1 here and 1 here. And 1 times 2 is equal to 2. Okay, so actually we just sorted out because we have seen the number 2 for the new number as the first digits and then drop down. So because this 2 was actually moved from the last digits of the old number. And if you double check, so now currently the value of new number is twice of the old number, and the old number ends with 2, new number starts with 2, and all the other digits are the same. So you may ask here, because we have already got 2 here, why we didn't stop this question at this point. This is because here, even we wrote 2, but it was actually 12. It's not really 2, so it does not count. We have to see the real 2 as the first digits and to end this question. Okay, so the final answer for this question is this. And if you are interested in about how to pronounce it, it is 105 quadrillion, 263 trillion, 157 billion, 894,736,842. Phew. Okay, so this question is pretty hard, and if you have worked it out by yourself, many congratulations. Thank you.